Happy June 4th. We are almost done. This is our final chapter, and we're going back to the very beginning. We are going to chapter 12. We're doing 12.1, day 1, and we're covering examples 1 and 2. And our goal is that you will be able to estimate points. Estimate limits at a specific point. And hopefully you remember what we did back in chapter 1. But if not, we're going to kind of take it slow and go through that. So if you will recall, we have limits and end behavior. And we did a bunch of that in chapter 1 and 2. And so if we had an equation like looking at the end behavior of f of x equals x squared, where does that go? Oh, as it goes to positive and negative infinity, it looks like that. And so we still wrote that the limit as x approaches plus or minus infinity, f of x is infinity. And so, and if, I don't know, some of you had a real hard time with this. These are two statements. One is the limit statement, and then one is where it's going. So that's for end behavior. Today we're looking at a specific point, and that is when we had like holes, discontinuities, etc. And so if you recall, in order for there to be a limit, it must be approaching the same value from the left and the right. So in order for limit to exist, must approach the same value from the left and right. And so we're going to use our calculators to create tables because we are going to be estimating limits numerically. So here we go. Example, we want to find the limit as x approaches negative 3 of the equation 1 minus 5x. And so if you will recall, what we do is we first find f of negative 3. We plug that in, 1 minus 5 times negative 3. Oh, that's 1 plus 15, so it's 16. And then we make a table of values. We plug negative 3 in the middle. And then we add and subtract point. Oh, look at this. We have whiteout. Woohoo! I did that intentionally. I wanted to use it. Negative 0.299. Oh, we add and subtract 0.001, 0.01, and 0.1. Negative 2.99. Negative 2.9, negative 3.001, negative 3.01, negative 3.1, and we found this to be 16. And we plug these values into our calculator, and I get 16.5, 16.05, 16.005, and sure enough, this is 15.995, 15.95, and 15.5. And so it is approaching 16 from the left. It is approaching 16 from the right. So there is a limit. And we say the limit as x approaches negative 3 of 1 minus 5x equals 16. And so your homework today is going to ask you to support your answer numerically. That means you will be creating a table. Eventually we won't be creating a table, but we will go from there. So I've got a your turn for you. We'll just do one your turn. Why not? The limit as x is approaching negative 1 for f of x equals x squared minus 4x minus 5 over x plus 1. So go ahead. Pause your video. create your table, evaluate it, and then turn it back on and check your answer. All right, well, hopefully you guys rock this. And when we do f of negative 1, we get 1 plus 4 minus 5 over 0, 0 over 0, so it's undefined there. I'll plug negative 1 in the middle. Negative 0.999, negative 0.99, negative 0.9, negative 1.001, negative 1.01, negative 1.1. This was undefined, but when I plugged in negative 1.1, I believe I got negative 6.1, and this I got negative 6.01, and this I got negative 6.001, and here I got negative 5.999, negative 5.99, negative 5.9. So as I approach from the left, I'm approaching negative 6. As I approach from the right, I'm approaching negative 6. So we would say the limit as x approaches negative 1 of x squared minus 4x minus 5 over x plus 1 equals negative 6. This doesn't have to be the same if it were to be continuous. But we're not looking at continuity, we are looking at limits, and we're going to take this to the next level. But that is step 1. And there you go. Have a good day.